Okay, so this is going to be the lab report for the first lab of Physics 2211, which is going to be over constant velocity. In this lab, we discuss Newton's second law by observing an object traveling at a constant velocity. And we're also going to see the difference between a physics simulation in real life versus on a computer. In this lab, we're going to assume that there's no air resistance or friction of any kind. We're also going to assume that the force of normal, or the ground pushing up on the object, is equal to mass times gravity, which means that we're going to assume we are working on a flat surface that isn't going to go uphill or downhill, which could cause acceleration to the ball. We're also going to assume that this object is moving in a straight line. Important principles for this lab are, one of which is Newton's first law, which is an object at rest will stay at rest unless acted upon by an outside force, or with motion, vice versa. And we're also going to need Newton's second law, which is the change in motion of an object is directly proportional to the magnitude of a force applied, which is approximately equal to acceleration equals force net over mass. We're also going to need to know the position update formula, which you can see there on the right. We're also going to need the velocity update formula, which you can also see on the right. For this experiment, we're going to observe constant velocity as an object moves. We're going to need a system. In my case, it was a wheel of tape, or a roll of tape, and we're going to assume that there is no friction, air resistance, gravity, or anything else acting against the object, and that the only force applied is going to be the one which put the object into motion. The initial conditions mean that the position starting off will be 0 meters and the time will be 0 seconds. And the computer model we're going to need is going to be generated with Glowscript. As you can see here, here is the video of my tape being rolled across the foot. You can hear my roommate also talking in the background there, please forgive me for that. You can see here some of the data points that tracker logged as that tape was rolling over that time. So we're going to see that the initial position is 0 meters, and you can see the initial velocity is calculated with that formula. We're going to see that via tracker, that is the initial position, and that's the initial velocity that you get from it. Here you can see that over time, the position is somewhat shaky, which can be due to a variety of things, which can be the tracker acting up, it could be from the tape rolling in a weird way. You can also see that the speed initially has to ramp up from time 0 as the force is applied to the tape. To model this in Glowscript, we're going to need to know several things. Here you can see that the mass has been replaced with 0.2, which is 0.2 kilograms, which is approximately the weight of that roll of tape, which is important to this. You can also see the initial velocity, which you found from doing that, is going to be equal to approximately 0.18 meters per second. Here you can also see my time step, which was the overall time divided by the distance traveled, which was, I believe, 1.74 seconds divided by 0.36 meters, or approximately 1 foot. And you can see here that 1.7 seconds is going to be the whole time of the simulation. You're also going to see the vector time step, or position step, and velocity step are equal to that 0.18 meters per second. As you can see here in the computer model, the ball rolls in a straight line, uninterrupted, unacted upon by any outside force, which is not true to reality. Which you can very much see here when comparing these two graphs. You see a nice straight line for the computer data of position versus time, and you see the shakiness of this line for the actual experiment data, which, of course, indicates that something's going on. So what if the x-axis was flipped? You would get the same charts, except the data would be going in the other direction, as the magnitude of the force would be the same. However, the rate would be different, as the direction of the force would be opposite, which would give you the same graphs, except they'd be going down slope instead. What does this mean? Can you find the net forces acting upon the ball, or the tape, from this? No, you really can't, because in a computer model, it's possible to make everything equal to 0, but in reality, you have air resistance, gravity, friction, and no surface is truly level. Also, you can see that air resistance would unlikely, a unlevel surface could cause positive acceleration downhill or deceleration. Errors, there's likely code errors here, and there's also friction forces. If you look at the video, the tape very clearly rolls off to the side slightly. So that would add time to it. Also, I very likely made coding errors and tracker. I probably clicked in places where I shouldn't have, and it was probably improperly calibrated. So that would definitely impact the data for here. But otherwise, that is all, and thank you for listening.